Alright, hell yeah. So in my studies, I had an aha moment. I was trying to add these two numbers. We have 3 square root of 3 plus the square root of 3, all in that numerator, and I was just like, I don't know how to do it. But then I was just like, oh, no, duh. Even though that these are kind of funky, you can just treat it, like they're, I don't know, it'd be like 3 oranges plus 1 orange. I was just like, oh, I never even thought of that. Like the number outside of whatever funkiness is going on is kind of irrelative to the number of the things that are funky. You know what I mean? So that's just 3x plus x, hell yeah. And you're going to have, and then you can even put a 1 right here. So this is going to be 3x plus 1x. Then you can FOIL them out, 3 plus 1. And then, but yeah, you can even do it 8 plus 4 using that same strategy. It just blows my mind. You can say this is 2 times 4 plus 4. And then you're going to say, well, this is also 2 times 4 plus 1 plus 4. See how I put the 1 in there? And now we got 2 whatevers plus 1 whatever. So we're going to have 2 plus 1, we're going to have 3 whatevers. And hell yeah, we get 12. Alright, so I definitely want to make shorter videos, but I do want to go over, this is one of the trickiest things, is that in one of my problems we had a x-axis and a y-axis, and I guess I have the problem right here. Hell yeah, they're saying when this thing goes in like this, for sure this point B kind of moves, well, it moves that way, you know what I mean? So cool, the point B moves there. But they don't want to know how it moves in this x and y. They want to know how it moves in x prime, y prime. And man, it's like the worst. So my strategies, or I guess it's like literally the only way to do it, maybe you got a better way. But we do have the x-axis and the y-axis. So what I'm going to do is draw out the I prime and the j prime, and I'm going to make them into vectors that are a unit of 1. You know, it's kind of your unit vector, but whatever. And then the crazy thing about this is you kind of just have to like, hey, cover up 1 for now, and this one, let's get this vector. And I think what happens is, you should have a better way to label this, because it just, I don't even know what that means. Is that a vector? Sure. But anyway, so we need to get this in terms of just the x and y. Okay, I think I can do that. So in the x, if this is 1, we're going to go over cosine 30. And in the y, we're going to go up sine 30. Cool. And then we're done with that one. So now we need to come over here. We made this vector, it's 1. And hell yeah. So this is the other thing that I need to get more used to, is like, hey, start your angles from this direction, and start them from here and sweep them all the way out. So if I have a vector down this way, hell yeah, so we're gonna sweep out 90, 180, and then you know what I mean, another 30 more. So that would be 180 plus 30, 210. But anyway, so we're doing this one. We're gonna sweep 90 plus 30. I don't even know if I got that one right, but anyway. So we're going to, 90 plus 30 is 120. And so to get to this location, so this vector has a component in the x, and it's going to be negative, but we're still just taking 1, the length of the hypotenuse, times the cosine of 120, and that's going to give us a negative whatever. Sweet. And then what does it give us? Oh, I don't even know. Oh, I even messed it up too, because yeah, this would be a. Oh no, we didn't mess up this one, because we just used this problem to do this. We didn't even do this one, but hell yeah, that would give you a negative 0.5, and then up you're gonna do sine of 120, and so sine of 120 is going to be in the positive direction, and it's going to be 0.866. All right, sweet. But now you got your two vectors. And so in the problem statement, we got a velocity of that point B, and it's going to be going over 1.5 and up 0.866. We just don't know in what components it's going to be. So what you do is you take this velocity vector and you dot it, do the dot product, which no one likes to do, with just kind of one of these vectors. So if you want to know how much of this thing is going in that direction, you just take this and dot it with that. So that's what we did, and we're going to take 1.5i plus 0.866j, that was this, and we're going to dot it into the direction of this new direction. And it still has two components, one in the original direction and one in the original, like y and x, anyway, x and y. And so when we dot these together, we get to multiply the things that are the same. So 1.5 multiplies with cosine 30. 0.866 gets to multiply by sine 30. And when we multiply them, cool, we also add them together. So it's just kind of a multiplication and add. So you add similar things, you multiply similar things, and then when you're all done, you add them, and you just get one value. It's a scalar component. And what does it say? It's like, hey, how much of this vector is in that direction? And so we get 1.5 times 0.866 plus 0.866 times 1.5. And this is probably the other aha, sorry it took so long to get there, is 0.866 is the cosine of 30, and it's with 3 decimals, that's a pretty accurate. It's like 0.866025 or something. But it's also, hey, let's figure out what this is and why. Because with sines and cosines, haven't you ever heard like, hey, sine squared theta plus cosine squared theta is equal to 1? Well, hell yeah. And this is a unit triangle. And so, so booyah, if we have this side squared, if we square this side, we're going to get 0.25. Cool. So that would be 0.25. And you're going to add it to something squared to get 1. Okay, well this something squared has to be 0.75. It just has to be. And guess what's inside this something squared? That's 0.866. So who knew that cosine, what is this? Sine 30, cosine 30? Cosine, who knew cosine 30 was just 0.866 squared? But that's going to be the square root of 3/4. Because if we take the square root of 3 divided by 4 and then we square it, cool, what do we get? Well, we get 3/4. Okay, so this is where we can, so now we know this 0.866 is just, well, that's just the square root of 3/4, and I think you should memorize that and just be done. But then, you know what I mean, everyone loves to simplify things, and then no one knows where the hell everything came from. So we're going to simplify this. So we can say this is square root of 3 divided by the square root of 4. And we know the square root of 4 is 2. So we got square root of 3 divided by 2. Hell yeah. So that's how over here I said 1.5 was 3/2. And this 0.866 was the square root of 3 divided by 2. And then we're going to multiply similar things. I don't even think I did this right. Holy hell. Cosine 30. No, cosine 30 is 0.866, so we're good there. And then sine 30 is 0.5. So we're going to have 1.5 times that square root of 3 divided by 2. Then we're going to have square root of 3 divided by 2 times 0.5. Booyah. And so that's where the denominators multiply to 4. And then the numerators, that was the whole point of this video. But hell yeah. So, and then that was just doing one thing. And what did that give us? That gave us, and then how do we simplify? So great, we're going to have 4 square roots of 3. Cool, so the 4's cancel, and we got square root of 3. And even, it's just so bizarre that I got this answer, and it was just like 1.732. And I was just like, that's a bizarre number. And I just totally forgot that I didn't even know the square root of 3 was 1.7. I've known that. You know, I definitely need to memorize it. And check it out, it's 0.5. So if you memorize it to 3 digits, you're almost like 100% on that one. And we got 1 more minute before my camera dies. But then in the problem, I was just like, well, what the, is this the square root of 2? Like, I just took this number and then divided by the square root of 12. And I was just like, oh, so it's the square root of, 12 divided by 2. And I had no idea it was just the square root of 3. So I just kept thinking this number was like the square root of 12 divided by 2. And I was like, how does that work out? Well, we can factor 3 times 4, so that's the square root of 3 times 4. And then we got square root of 3, square root of 4. Square root of 4 is 2, so we're going to have square root of 3 times 2 divided by that 2. We get the square root of 3. Alright, anyway, so hell yeah, that's just 10 minutes of total nonsense. But I think we did it. But this is the stuff that I get kind of excited about. I'm just like doing my coursework and stuff, and I'm just like, oh hell yeah, everybody wants to know that... you know what I mean? It's kind of like, I think we did it. So anyway, thanks for joining me, and that's a video.